Okay, let's move on to chapter 2. We're going to learn how to summarize and graph the data. Once you collect the data, then you can collect data first. And after that, we summarize and graph the data. We have different tools we can use to graph the data. Let's take a look at this CVDLT, which is center, variation, distribution, outlier, and then time. So center is representative value that indicates where the middle of the data set is located, or the center of the data set is located. Variation is a measure of the amount that the data values vary from each other from the center. And distribution is nature or shape of the spread of the data values over the range of the values. So you could have bell-shaped, uniform, or skewed. Okay, I'm going to talk about all these different type of distribution later on, maybe from chapter 3 to 4 and 5. Okay, and outliers is those extreme values. Extreme values is the data values that are very far away from the majority of the data values. So we also call that extreme values. Okay. Meaning if you have extremely large numbers or extremely small numbers, that could be a potential outlier. And time changing characteristic of data of the time. When time changes, sometimes the characteristics of the data also changes. So this is what we call a CVDLT. You can just remember that as CVDLT. And that's the most important characteristics of the data values. Okay. And we try to organize the data and summarize the data by constructing a table called frequency distribution table. Okay. So this is the most important table on the graph we're going to learn starting this in chapter 2. A lot of computer software like Excel, SPSS, SAS, all those different softwares and calculators could generate frequency distribution. We're going to talk about detail of how to construct it later on in this particular section. All right, so let's talk about the definition of frequency distribution or frequency table. Basically, you just partition a data set into several categories. We call that classes by listing all of the categories along with the number of data values in each one of them. And this number of data values for each classes is what we call a frequency. So two important things for frequency distribution table: classes and frequencies. And you construct a table based on that, right? You come up with a table according to these two major categories. Okay, and this is a typical frequency distribution table. Frequency distribution. And this one is about IQ score of the low lag group. You know that lag has a very negative impact on a child's brain development. So low lag meaning the child's brain could develop much better. So IQ score, let's look at it. So in the first class is what we call the 50 to 69. So class number 1. Class number 1. From 50 to 69. We have second class, right? Class number 2. It's from 70 to 89. Okay, class number 3 is from 90 to 109. class number 4, from 110 to 129. Last class, class number 5, turned out to be 130 to 149. Now you also have frequencies here. So for the first class, frequency is 2, second class, frequency is 33, third class, frequency 35, and 7, and then 1. Okay. And lower class limit are the smallest numbers within each class. So if you look at it, 50, 70, 90, 110, 130, if you list lower class limit for this frequency distribution, $50, 70, 90, 110, 130. And if you look at it, the increment is 20, right? So adding 20 to 50, you get 70. And then you get next one. So difference is 20 here. Adding 20 to 7, you get 90, 20, and 20. And now so in order to get next class, lower class limit, you can add 20 to previous one to get next one. Yeah. So now that's a pattern. That's a pattern of all this lower class limit. Now let's take a look at the upper class limit. Okay. So for the upper class limit here, it's the largest number in each class. Okay, that's the definition of upper class limit. So you're going to see 69 largest number in each class. So the upper class limit for this frequency distribution table, and if you look at all these numbers, again, it has a pattern: 69, 89, 109, 129, and then 149. So if you're adding 20 to 69, you get 89. You're adding 20 to 89, you get 109. You're adding 20 to 109, you get 129. You add 20 to 129, you get 149. So again, it's increment of 20. So it follows the same pattern as lower class limit. Now let's take a look at class boundaries. So now class boundaries are the numbers used to separate classes, but without a gap created by the class limit. So now let's take a look at how they come up with the second class limit, class boundaries. Okay. So 69.5, they basically just look at between first class, second class, between 69 and 70, they pick a neutral number, which is the middle of those two numbers. 69 plus 70 divided by 2, that's 139 by 2. That's how you come up with the 69.5. Same thing for 89.5. You just adding 89 and 90. 89 plus 90 and divide by 2. And you get 179 by 2. That turned out to be 89.5. Same thing for the rest of them. Now if you look at the number, again, it's increment of 20. Right? So you're adding 20 to the previous one. You get next one. You get another 20. You get next one. Another 20. Another 20. Right? And again, that's class boundary before the first class. Typically, you just use the second class boundary, which is 69.5, subtract by 20, and you get 49.5. So again, you follow the same pattern as lower class limit and the upper class limit. It's an increment of 20. Right? And now let's take a look at class midpoint. Class midpoint are middle of each class, meaning you just simply add in the lower class limit plus upper class limit, and you get class midpoint. So you add in 50 plus 69 by 2, you get 119 by 2, which is 59.5. And second class, very similar, adding 70 by 89, divided divided by 2. So that's 159 by 2. That turned out to be 79.5. Same thing for the rest of them. Third one, you just add in 90 plus 119 by 2. That's 209 by 2. And okay, yeah, and then okay, yes, no, 109, right? So it's 199. Okay, so there's a little mistake here. Let me just erase it. $90 plus 109 by 2, so that's 119 divided by 2. That turned out to be 99.5. You can get the rest of them follow the same formula. If you look at the pattern right here, it's also increment of 20. If you're adding 20 to the previous class midpoint, you get next one. Same thing here, adding 20 to get next one, adding 20 to get next one. And then the pattern here is an increment of 20. And now let's talk about this 20. 20 is what they call the class width. Okay. Class width is difference between two consecutive lower class limit or upper class limit. So the class width could be calculated as two consecutive lower class limit is 70 minus 50, you get 20. Okay, you can use or you use a consecutive upper class limit. So using 89 minus 69, that's also 20. So picking any two of this consecutive lower class limit, upper class limit, you get a class width. And class width is the pattern, right? All those lower class limit, upper class limit, class boundaries, and also the class midpoints. They all follow the same pattern. It's an increment of the class width. Okay. And now the reason for constructing frequency distribution table, because usually we have a large data set, you can easily summarize using a frequency distribution table. Also, you can analyze the nature of the data. You can look at the distribution of the data and analyze it. And I will also have a basis for constructing important other graphs. And next thing, let's take a look at the procedure of constructing a frequency distribution or frequency table. First of all, determine the number of classes, and typically it should be between 5 and 20. And if you work for the company, usually the project director will decide on how many classes desire to have. Okay. And then second important step is calculate the class width. So again, rounding rule here is always run up. Okay, we want to make sure we cover all of those data values. So rounding up will make sure we cover all of those data values. Make sure each one of the data values from the smallest to largest have a class to go to. Okay, so class width is approximately equal to maximum value minus minimum value over number of classes. That's predetermined. Yeah. So, and then the starting point, usually you will pick a minimum data value as starting point, or the convenient value below it as the starting point. And for example, let's say from that previous example, we determined that we're going to have 5 classes, right? IQ example. So first, we determine 50 is the lowest data values in the data set. So we use 50 as a starting point. Now we need to determine the first upper class limit, right? X. And we know that we need to have a class width of 20. So you can set up a simple algebraic equation to solve for the first upper class limit. So you do x minus 50, adding 1, that must be equal to 20. 20 is class width. So this is x minus 49 equal to 20. And if you're adding 49 from both sides of the equation, you get 69. Okay, so that's why the x equals 69. Then the first upper class limit is 69. Now from there, you'll be able to add 20 to get next one. Add 20 to get next one. Add 20, you get 110 to 129, and add 20, 130 to 149. All right, that's how they come up with all those classes, and this is the rationale behind it. Okay, and once you have the first lower class limit, and then you just add class width to get next lower class limit, eventually you get the rest of them. Okay, just like what I did, I add 20 to 50, I get 70, another 20 you get 90, another 20 you get 110, another 20 you get 130. Upper class limit, same thing, you just add 20, and you'll be able to get all those upper class limits. And now you complete the classes, and then you just tally the data set and figure out the amount of the data values for each classes. Then you complete a frequency distribution table. All right, and this is a detailed procedure how you construct the frequency distribution table with a given data set. Okay, and let's take a look at relative frequency distribution. So the relative frequency is basically the class frequency over total frequencies, right? So each individual class has a frequency divided by the total frequency, and we come up with a relative frequency. Also, percentage frequency, you're just using class frequency over total frequencies by 100%. So let's take a look at how we will come up with a relative frequency distribution. So first of all, how they get this 2.6%, what they do is using 2 divided by 2 plus total frequency. Or if you want to do a total here, that's fine. Just sum up all those numbers, and let's see what that is. 2 plus 33, adding 35, adding 7, adding 1. And that turned out to be 78. So total is 78. So you get 2 over 78. And if you turn it to decimal answer, this turned out to be 0.026. If you run it to 3 decimal places and you convert this decimal number to percentage, that becomes 2.6%. And that's how they come up with this, right? So the second, you do the same thing, 33 over 78, and that's approximately equal to 0.423. You turn into percentage is 42.3%. Same thing for the third class. Relative frequency is equal to 35 over 78. So you turn into decimal and percentage, become 44.9%. Second to the last class, 7 over 78. And convert it to a decimal first and then percentage, you get 9.0%. The last one will be 1 over 78. Okay, and that turned out to be 1.3%. And if you sum up all of this percentage, you should come up with 100%, right? Typically, that should be the case. And if sometimes, come up with something 9, this is 993. So due to rounding, you may end up with 100, not exactly 100%, but approximately equal to 100%. That's okay, because in this case, it's probably not equal to 100% exactly, but due to the rounding errors, right? Because we round it to 3 decimal places, so that's a rounding error. But typically, if you sum up those relative frequencies with right rounding numbers, you should get 100%. Okay. And now cumulative frequency distribution table. You just accumulate frequency from the previous classes. So for example, for the first class, you accumulate just first class, so you get 2. For the second class, you accumulate the first two. So adding 2 and 33, you get 35. Okay. And then third class, you accumulate the first three classes, 35 plus 35, you get 70. Okay. And then fourth class, you accumulate first four classes. So you're adding first four frequencies, 70 plus 7 gets you 77. And by the time you get the last one, you're adding all five frequencies. So you come up with the total frequency 78. Okay. And that's how we come up with the cumulative frequencies. And all these different distribution are used to create different graphs. And you're going to see the graph in a bit. So once you construct the frequency distribution, and if the distribution look like bell-shaped, for example, once you graph it, you may come out with something like this. And this will fit a bell curve, right? Upside down bell curve. This is what they call bell curve. And if you see a bell curve, then typically we call this as a normal distribution. And this is one of the most important distribution utilized in statistics. And it has a very heavy application in every industry. So normal distribution, pay attention to that. If you see the bell curve, you have a normal distribution. And typically for the bell curve, it starts low, meaning it starts with the low frequencies and increase to the maximum, and after that it decreases. Right? Then typically symmetrical with respect to the center. So two important features: start low and increase to maximum frequency and then go down. Right? Also symmetrical. Right? So and the presence of gap can show that we have data from two or more different populations. And let's take a look at one of this example, what they mean by the gaps. So the table on the next slide is frequency distribution table, or randomly selected pennies. And the weights of pennies are presented, and the examination of frequencies suggests they have two different populations. Pennies made before 1983 and 95% copper and 5% zinc. And pennies made after 1983 are 2.5% copper and then 97.5% zinc. Okay. So if you look at it, the distribution look like this. So if you look at the center area here, in the middle, you see frequency all zeros. So that means the data values are concentrated on the first two classes and our three classes. So that just suggests that this data set come from two different populations, right? So that's what